Hello everyone, this is a short video about revision of probability. Number 1 here. The letter of the word prince are written on the card and one chosen at random. Find the probability that a vowel will be chosen. So start with number 11. So the word prince. Simple outcome is P-R-I-N-C-E. Simple outcome of vowel E-I-N-E. So easy too. The probability of vowel equal the number of successful outcome I-N-E 2 over the possible outcome. 1, 2, 3, 4, 5, 6, 2 over 6. Simplify. Dividing by 2. 2 to 2 give 1, 6 to 2 give 3. So equal 1 over 3. Alright, let I change the color. Now that done, you see 1 over 3. So whenever you done a 1 and you feel, I'm confident with that, you can tick on that and keep moving on. Number 12. A spinner with the number 1, 2, 3 is spun and the card and number 80 has it handwritten. Write the probability of an odd number being spun and letterhead being chosen. So we need to use a table here. It tells you about using the table. So I create a table first. Spinner 1, 2, 3, card A, T, has S. So let's combine them together. 1A, 1T, 1H, 1S, 2A, 2T, 2H, 2S, 3A, 3T, 3H, 3S. So the thing we are caring about is odd number being spun and letter H. Odd number with letter H, odd number with letter H. 2H doesn't count because it have an even number there. So probability of odd number with letter H equal to successful outcome out of all the possible outcome. 4 times 3 equals 12. 2 over 12. Simplify at 1 over 6. So whenever you're done, moving to the next one. Number 13, tree diagram. Number 13, tree diagram. 3 fair coins are flipped. Use a tree diagram to find the probability that exactly 2 of the coins are heads. So whenever you flip a coin, you have 2 possible outcomes, heads and tail. So that is the first time you flip that is the first coin. The second coin, it could be head, tail, and the next one, head and tail, heads and tail, head and tail, and head and tail. First coin, second coin, third coin. So let's write all the possible outcomes. That one gives you H, T, H, T, H, TT. Keep going on. THH, THT, TTH, and TTT. So, if you are not sure that you have enough the possible outcome, it is so easy. The first time you flip the coin, you have two possible outcomes. The second time, you have two possible outcomes. The third time, you have two possible outcomes. So you should have a possible outcome together. Alright. Now, it says that the probability exactly two coins so heads. It said that exactly two coins so head. It doesn't say head in the first or second time. So anyone that have two heads all count. 1, 2 heads, 2, 3, 4. 1, 2, 3, 4. No more. So hold on, why I have the one with the same here. Sorry, I should check. That one should be head TT. So let's count again. 1 with 2 heads, 2 with 2 heads, and 3 with 2 heads. So whenever you lead the outcome, you need to double check like I got a wrong one already. So without double check, your answer should definitely got wrong. Alright. So the possibility exact 2 head equal 3 out the all possible outcome, 3 out A. So whenever you're done, you can move on to the next one. Number 14. Of 50 people, were found that 20 people like both tea and coffee. 15 like coffee but not tea. And 10 people like tea but not coffee. Draw a diagram. Alright, firstly, diagram is include 2 overlap circle and 1 rectangle. A lot of my students, they prefer like 2 circle and they put another circle for the people who don't like either coffee or tea. No, please do not do that. I want 2 overlap circle. So if 2 of the event that you have do not have anything intersection, that 2 circle not overlap each other, that should be okay. So putting here, people like tea and people like coffee. Reading again. 50 people in the survey, the universe said equal 50. 20 people like both tea and coffee, the intersection part here. 15 people like coffee, not tea. 15 there. 10 people like tea, not coffee. They do not mention how many people don't like neither coffee or tea, so we need to figure it out. We already have 10 plus 20 equal 30 plus 15 equal 45. So 50 take away 45 equal 5. So 5 people doesn't like neither coffee nor tea. So draw a Venn diagram. Yep, we're done. Find the number of people who like coffee or tea or both. Remember, it's E inclusive or you already include the or intersection part here. So tea or coffee or both equal tea 10 plus coffee 15 plus both 20 over the whole population who would involve in the survey. 50 equal 45 over 50, simplify by 5. 45 go to 5, give you 9. 50 go to 5, give you 10. 9 out of 10. Alright, let's move on to the next one. 15. of 50 people, it's found that 20 people like tea coffee, 15 like coffee, not tea, 10 people. Draw a two-way table of the situation. I back to the question that we worked before. So the difference between the Venn diagram and two-way table is the two-way table, it has additional column about total. So you have here, you have tea, don't like tea. You have coffee, don't like coffee. So some people can feel like which way we put it. Should I put tea next to coffee and don't like tea next to don't like coffee? No, please don't do that, because your table gonna get wrong. So the first one here, people both like tea and coffee, 20. Here, people like coffee and don't like tea, 15. Over there, the people like tea but don't like coffee, 10. Over here, the people don't like tea, don't like coffee, don't like anything, 5. Alright, the two-way table, you need to have additional total. So 20 plus 15 gives you 35, plus 10 plus 5 gives you 15 equals 50. 20 plus 10 over here, total gives you 30. 15 plus 5 gives you 20. So to double check with the two-way table, whenever you add it up vertically or horizontally, it should have the same result in the corner. Alright, that's it for 15. We move on to the next one, 16. Or I can use two-way table to calculate probability. The eating and sleeping preferences of your animal are shown in the below. Find the possibility of an animal that sleep during the day, do not eat meat. So we care about sleep during the day, not eat meat. So the one who sleep during the day over here and not eat meat over here. So that should be the intersection here. We have 12 out of the whole population out of 100. Simplify by 4. 12 to 4 give 3. 100 to 4 give 25. All good. That question a bit short. Move on to the next one, 17. Rest white orange marble in a jar. So we have 3 possible outcomes here. Repeatedly a marble taken out, it is noticed, the color is noted whenever we take it out, and it is placed back in the jar. Given that time, so we have a trial. Given that a time with red, 12 white, 10 orange. So how many trials they have? A plus 12 plus 10 equals 30 trial. So that one, it comes to experimental probability. So experimental probability, quickly explain, is E, found by repeating an experiment and observing the outcome. Alright. So state the experiment probability of red marble being chosen. So let I write PR, experimental probability of an event, equal number of time event occur over total number of trial. So probability of red marble. So how many times red occur? A, out of total number of trial, 30. 8 over 30 simplify by 2. 8 to 2 give 4, 13 to 2 give 15. All good? 2 more to go and we're gonna finish soon. 18. If the probability selecting an O-ring is a third, it should be linked to the previous question. What is expected number of time an O-ring member was chosen over 600 of time? So we have one formula that expected number of occurrences equal probability multiply number of trial. So expected number of O-ring occurring equal probability of O-ring 1/3 multiply number of trial 600. Without calculator, we need back to the multiplication of fraction here. 600 simplified by 3 give you 200. 3 to 3 give you 1. So 1 over 1 times 200 equal 200 times. So we can say that a third of 600 is 300. So the O-ring expected to occur through 200 times. Let's come to the last one. 19 is a bit long. I'm gonna move in a new page. So number 19. A tennis player has a 1 in 2 chance of getting hit first serve. Is going in, he has 1 in 6 chance of losing a point. Design and run a simulation to estimate the probability that he get hit first serve in and win the point. So firstly, the tennis player have 1 in 2 chance of hit first serve in. So 1 in 2 chance, it remind you about flipping a coin. So if you flip a coin, so you also have 1 in 2 chance of head and 1 in 2 chance of tail. So let's flip a coin, you have 2 chance. You can either have head or tail. So whenever you have heads, it can count at a fault. And you have 1 in 2 chance of surfing. First surfing. And whenever you have the first surfing, it has 1 in 6 chance of losing the point. 1 in 6, so it remind you about rolling a fair dice, so roll a die. So 1 in 6 chance of losing a point. So for example, 1, 2, 3, 4, 5, 6. If you rolling 1, so the probability of rolling 1 is 1 out of 6, so you losing a point. And you can have either 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So you have 5 in 6 chance of winning a point. So now you need to actually do the experiment and you need to run a simulation to estimate the probability. So let's see all the possible outcomes that you have here. The first possible outcome may come from here to there. The second possible outcome run from here to there. And the third possible outcome it come from here to there. So the possible outcome. So thirdly, first serve but not in. Secondly, first serve in but losing a point. the last one, first serving, winning a point. So highly recommend you create a tally table. So whenever let's call you have 3 different possible outcomes here, A, B, C. So whenever you roll a dice, whenever you flip a coin first, whenever you flip a coin, you have a head. So add 1 to A over here. And whenever you flip a coin, you have tail. After that, you need to rolling a die. Flip a coin head and rolling a die. If you have number 1, it come to here. Possible outcome number 2, add 1 to B over there. And the last one, when you flip a coin, you have a tail. You're supposed to roll a die. You have any number but not 1. It come to here. Outcome C, as 1 to C. So that's how you design and run a simulation to estimate the possibility that he get hit first in and win the point. So the more trial you have, the more exactly probability you have. And that is the last question of the revision probability. Good luck everyone. Thank you.